Start.
Go.
Hi. I know. It's that moment when you realize it's the end of the course and it's just everyone is sad because there will be no more classes, right?
Yeah, I'm gonna cry.
But on a cheery side, those who don't make it can redo the calculus. I'm just kidding. Anyway, so yeah, this is the end of the course. We have the final exam scheduled for tomorrow. Hope you all show up. Final exam is whatever the syllabus says plus whatever else syllabus says, which is 45%. Nice. And the final exam is covered in the learning outcomes. So we'll go through that. But before, since we have so many visiting students, faculty of RVCC is not supposed to email any grades to anyone. So do not send me emails asking what your grades are. If you want to know particulars about your grade, make the appointment with me in 2 weeks, because next week the college is closed, or whatever time in July. I will show you, I can show you the final, I can show you all of the individual grades, and you can also do your own calculation if you think that I can't do percents. Anyway, the final grade for the course, which is the letter grade, will be only thing that it's visible to you in Lion's Den. So you will log into Lion's Den and you will go to the student services and you will click on the final grades. So when you go to the Lion's Den student tab, there will be view final grades. Final grades, I will try to post your final grade on Friday. However, the school also takes time to do some procedure called rolling grades, whatever the hell that means. And for all purposes, that is just making it publicly visible for you, because when I enter the grades and click the submit button, then there is still some procedure that registrar's office has to do in order for those grades to become visible to you. So I would say probably Saturday noon would be the latest, but then I wouldn't be surprised. Yeah. But then I wouldn't be surprised if it's also Monday, because if for whatever reason they don't roll in a Friday afternoon or Saturday morning, then they might roll them when they come into work, if anyone is coming to work on Monday. So the letter grades, right, A, B, C. Now, when you are transferring to a different institution, you have to request the grade to be transferred. With our registrar's office, you will request the official transcript to be sent to your institution. I believe it costs like $5 or something. You might be able to actually do that online as well. I'm not sure. You got to poke request official transcript. There it is. And then you read these many letters and paragraphs that are there. So the transcript will send. Now the grade will not transfer. You will only receive a T grade where you are, because that means it's transferred in. And it just means that you passed that class anywhere else, so this will not be calculated in your GPA, whether it's A or a C. These cannot be transferred, so if your grade is D, you are still able to graduate RVCC, but you are not able to transfer that grade because schools will not take transfer D. So don't email me for the grades. You will see your letter grade. And if you are interested in the particulars of your grade, please make the appointment, and I will give you all of your grades on a sticky note, and we can discuss anything you want.
Just to clarify, final grades like you're done calculating, like class prep, lab, final exam, all that, and just like a letter like B.
It's yes, yeah, it's B+. So that's the course grade. Yes. So for the entire course. And then individual grades that actually make up that grade, you need to see me if you want to know the particulars. So let's say a student had 3 A's in a row for exams, and then you log in and you see the final grade is B. Yeah, I think you would want to know what the hell happened, right? How is it possible, right, that you were running like 93, 96, and 97, and all of a sudden, right, you took the final and you think you did well and the grade is B. Why, right? So those are kind of things that that you might want to make the appointment for. Obviously, if your grade is like 57 and then 73 and then 84, and your final grade is C plus, then it's clear, right? So the final exam, which is tomorrow, is 2 hours, from 12 to 15 problems. I'll decide that tomorrow morning, I guess. I have time. The final exam is 2 hours long. It's in this room. We will start at 5, so 5 to 7. If you finish early, you can leave. Formatting for the final exam would be the same as formatting of every exam you took, with every other page being blank. You can use it as a scrap paper. There are no quizzes, there are no replacement problems or anything like that. Final is there to just assess what you learned in this class from day one unto the today. Now, when you are figuring out what's there on the final, well, what must be on the final are the learning outcomes on the page 2 of your syllabus. There are four bullet points which address different parts. So if you are unfamiliar with those, right now is the time to get the syllabus for the course, which is the last day. Would be the time to take let's take a look at the syllabus. So there they are, right on the screen. So compute with vectors in 3-dimensional space. So this is technically chapter 11, right? And then also directional derivatives and gradients. They're all vectors, right? So what's on the final exams? Vectors in 3D. And that's practically entire chapter 11 is covered in that statement, because you have the dot product, you have addition and subtraction of vectors, you have properties of vectors, you have the dot product, you have the cross product. You use the vector to create equation of the line, you use the vector to create equation of the plane, you use it for the tangent plane, you use it for, so your vector valued function is a vector of functions f, g, h. Your vector field is, right, the gradient in 3D. So all of these are vectors, whether you have numbers in them or functions in them. They're all 3D vectors. So that covers a lot. It's a one statement that it's not just chapter 11, but also concepts of a tangent plane from chapter 12 and so on. So the only thing that it's not included in this one is actually chapter 13. But it covers a lot of stuff. Also covers projection and work, right, and all of that good stuff. Now, the second part is the differentiate functions of several variables, including graphing functions of 2 variables. So this is differentiation. So this is focusing on chapter 12, right? Because chapter 12 is where you learn partial derivatives, directional derivatives, chain rule, right? All of those different differentiation techniques, which also included min-max and Lagrange problems, which also utilize the gradient, right? Which is vector of partial derivatives. So derivatives. But technically what it says is chapter 12. That's basically what the second one is saying. Number 3 says evaluate multiple integrals. Good effort. So evaluate multiple integrals. And as you are, that would be chapter 13. So you have the double integrals, the triple integrals, and so all of the stuff that you, right? So as you can see, each one of these is actually entire chapter without cutting out stuff. I don't like that they are not specifying application problems. There will be a Lagrange problem on the exam, 100%. So that's without a say. It's a 2-variable Lagrange, right? So you're not going to solve 16 equations, but the 2-variable Lagrange is still 3x3 system, right? And it's a nonlinear system. So look into Lagrange problems. You must have that. The last bullet point on the syllabus in the student learning outcomes is the utilize Green's theorem. I'm not too happy that it's so specific, right? We should say vector fields, which obviously includes all of the stuff. But Green's theorem happens to be the learning outcome that is singled out in many universities and so on, and we have to satisfy the transfer requirement. So Green's theorem, meaning the stuff we did today, you have 2 flavors of the Green's theorem, right? And then you have the curl and the divergence, right, or the circulation flux, right? So so that's that, and it should be a very straightforward. I mean, it's much faster to do the Green's theorem than to do the entire line integral. Yes.
You did like problems about other parts of chapter 14, or did you just focus on Green's theorem?
Well, we have to have a Green's theorem problem in there, so it's not focused. It's 100%. It's going to be there now. For other problems, graphing vector field in 2D or 3D is just very tedious, takes very long time. Solving line integrals the long way is a possibility. Figuring out if the field is conservative, that's great. I mean, that's short, you know, the short formula. So that's amazing. Now, calculating potential function, that's going to take an eternity, right? So, I mean, if you have 12 problems, I could sneak in a shorter version of either the line integral or the potential function. But then that really takes away from testing a lot of other stuff that, plus all of those things can be computed on the computer software today. So, yeah. You're looking into what other things? You're looking into the tree for, right? You're looking into the tree for chain rule, right? Making sure you can classify your critical points as min, max, or a saddle. I told you already, 100% Lagrange problem. You have to have a plane problem, whether it's an intersection plane with something or a tangent plane. So plane must be, equation of the line must be somewhere. The problem with the vector valued function r prime, r double prime, like velocity and acceleration, that should be also some. I mean, they all belong to other things discussed, but directional derivative is a good one. Directional derivative, right? Because partial derivative x and partial derivative y, they're only derivatives in direction of x-axis and the y-axis, but what happens if you want the direction? And also, I want to bring that up because I know I mentioned at least 17 times that you must have the unit vector when you are doing the calculation for the directional derivative, and then somehow some of you missed those 17 announcements. So I just made those announcements go up to 20. Let's see who misses it on the final. Well, now I have to make a 21st, since you are asking. Directional derivatives must use unit vector. Good. Yeah, so now that's 21.
Is there gonna be like easy stuff on there too, like just dot product, like how it was on the first test?
Yeah, you have to know the dot product, the cross product. So you could have a problem that says the good old 3u dotted with negative v, right? And then you go and you figure out what 3u is and negative v is, and then you do the dot product. Or find when I asked to find the plane and I give you 3 points, you clearly have to do cross product. So if you're doing the cross product in a problem, there is no need for standalone problem that says find the cross product. So these are the things. Some microwaves are. What else? What else we could talk about? So now, generally, people are freaking out the most regarding Chapter 13 and all of the integration that it's in it. So you have to expect both double and triple integrals to show. Now, you know that there are like levels of hell, right? You have just a plain vanilla problem where you have integral given and it just says compute, right? And you just go and integrate. And then you have those that say switch the order of integration and then compute. Then you have the ones that say change the type of the integration and then compute. I don't know which ones. That's probably individually, like student to student, which one is harder than which. In terms of switching order of integration, right? If it's a rectangular integral, you just swap. If it's something more involved, obviously you have to draw the picture and so on. I would probably stick it to the double integral for the switching the order. Now, what's important for changing the integrals, you have this idea, the notion within the polar and then polar and rectangular, and then you also have rectangular with cylindrical and spherical. So those conversions are necessary. So let's say you have to integrate e to the x squared plus y squared plus z squared. Right? As soon as you see that, you immediately know that you are supposed to switch it to the spherical coordinates. If you don't know that right now, then you don't know spherical coordinates, because knowing x squared plus y squared plus z squared is equal to rho squared, or square root of that is just equal to rho, is immediately telling you that you are supposed to switch to the cylindrical coordinates anyway. Because how are you going to compute? Yeah, it will be rho or rho squared, depending whether you have square root or not. There is no way for you to integrate z to the x squared plus y squared, or square root of that, make it even worse, right? There is no way to integrate that stuff because that's not even the trig sub at that point. You have three variables, right? So the same thing happens for the double integrals. As soon as you see a square root of x squared plus y squared, well, that's r. Or you see 4 minus x squared under the square root, well, that also screams half a circle, right? So, you know, there are those triggers that will tell you that you are supposed to switch the integration, otherwise you will be dealing with trig integrals and trig substitution and all of the things that you might not want to deal with. If the problem is too hard, if the problem is too crazy, you are most likely overthinking it, because you know, the final exam is not supposed to have the most challenging problems. Most challenging problems should be on the project, right? Because that's something that during the regular semester actually is assigned for 2 months. In your case, it's assigned for 2 weeks because your course is on steroids, right? But you know, when you are looking into a problem, you are either overseeing something that it's very simple, B, you don't know concept at all, right? That's possible as well. But if you are going into a 6-page calculation, you are definitely doing it wrong, right?
Well, what if it's a six-page napkin problem?
I will not final exam on a napkin and give you that, so you don't have to worry about that case. Yes?
Can you ask about like those weird polar shapes, like leaves and
they are not weird, they are standard.
Yeah.
Oh, this is the best answer I can give you. Because you can always graph them, right, by assigning thetas and then points and then tracing, like in the coloring book.
Will we need a calculator?
No, but yes. Means you don't need one, but you can bring a non-graphing calculator.
I don't have
So,
a
no, yes. It's 20 hours still, so you still have time.
Yeah. Do you want which normal?
Make sure you bring all of your stuff that you want to hand in tomorrow, because when I leave the college tomorrow, I'm not coming back till like July 10th or 11th or whatever the Monday is. So whatever you leave anywhere will probably be picked up by the cleaning crew, not by me. So when I leave tomorrow, having Calc 3 anymore, right after the final, you can get home and then you can get on homework and still work till midnight, and it will close at midnight, and then the course is over. Projects, make sure they're in mint condition, so bring them protected. Every bent corner is -3 per page. Look at that, perfect over there, right? So you have a terrible bag for this, right? Because it's that's your bag. The green is your bag. Yeah. So that one is like right.
I get it really quick.
I think it's a pretty nice bag. Even though it looks like a duffel bag.
Yeah, I mean, because it's right, it's going to bend, and then it's going to crumble the project. Make sure no one is touching. It was one of the funniest questions I had was 2-3 years ago when the student said, "Professor, what would you do if someone randomly just jumped at the pile and started bending all the corners and on the project?" I said, "I would do absolutely nothing. But whoever jumps in probably would be eaten by the rest of the class, because it's -3 per page, right? Of per page." No, your responsibility of full grade being.
It gets to that desk.
Yes, when it reaches the desk. If I bend, then I can't. Yeah.
You could just say it was like, "Oh, this kid."
Yeah, but whatever you want to do, you do not have to spend any money. A simple staple that is either 0 degrees, 90 degrees, or perfect 45 will do, right? But if you want to put it in some kind of folder, you can. There's this one folder that you should not use, and whoever designed that thing should be publicly shot, I guess. But just as an example to all other people, not to invent stupid things like that. There is this folder that is just a clear sleeve that is folded in half, and there is this plastic thing that slides on the side. Do you know how many times that falls apart with everything flying around when you open it? 100% of the time, that thing falls apart. And then your project is like everywhere, and guess who's not picking it up and putting it in order? Yeah, me. So that's the only folder that is banned for all eternity. If you're handing anything to me, other than that,
Hand me this folder. I burned the project.
yeah. So yeah, I promise I will not like you if I find that project on a file. Just thinking that you are trying to do the personal insult to me, right? So that's like, yeah, he said he hates it. Here you go. What are you gonna do?
So,
So no long like mass calculations.
No, but if you're requesting, I can make a special page added to your exam only. You're Spencer, right? No, he's Spencer.
So x squared.
What is that?
Y squared.
I don't know.
Are you gonna go over problems now?
I can.
Okay.
If people are interested, since you are interested. What happened? It's gonna be really?
No.
Then no.
Well, that's subjective. I don't know which one it is. One of those are.
Yeah.
What do you think the best way to study for this final is?
Yeah, you're right.
So, like Carly printed out like that sheet that's on the course website. So look at those formulas. Know all the formulas.
So you just want to make sure that you can solve everything from exams,
Yeah,
right? You can use any side you want.
Yeah, retake the exams, right?
Yeah, you want to look into exams. You want to look into examples I did in class. You want to browse through my notes. I just need to make sure that I have all the notes posted, so you can briefly run through those. So that's
Only up to 13.1 is up.
Do what?
Only up to 13.1 is up.
This is what happens when Liz annoys me after every class and I forget to post notes.
Talking about me?
No, I would never talk.
That's the bit.
Wait, can I have some nerve? I just want to know you stapled it on the corner.
Yeah.
Oh.
I feel like it's bent though.
No. Wait, so this is fine as staple? Like a 40... Like this isn't 45. Like you weren't...
Let me see. I'll tell you immediately.
Oh my lord.
It's so easy to spot.
Your quarter's already bent too.
Yeah. Look at these tips.
No, the corners are... that's... that's not 45, but...
Wait, what do you mean a 45?
45 degrees to the... it's not 45.
I have to measure it?
That's a 45-degree angle?
It's not.
No, it's not. It's obviously
not.
It's obviously less.
You folded
But
that. That's not...
That's -1. Don't sweat it. Don't sweat
Wait, so then where do we go to... Can we bring it in like without it stapled and have you staple it? No?
No.
Oh.
That's -3. That's worse. Stream is